Hello everyone, in this video we are going to see the concept of design engineering. In software engineering, design is one of the phase, and let us see how this design engineering is done. So let us see by this topic wise: introduction, design quality, design concepts and the design model. Let us see what is the purpose of design. Design is where the customer requirements, business needs and technical considerations all come together in the formulation of a product or a system. Okay, so here when the customer and the developer start discussing about the product, they come out of the requirements that is needed by the customer, and what is the reality or what is the necessity of the particular business model, and what are the technical things that can be considered. So all these things are put together in mind and they form a product or a system that is called as a design. And now the design model provides detail about the software data structures, architecture, interfaces and components. So in this design model, they find out what are all the components they are going to build and how these components are going to interact with each other, that is due to the interface, and then how the architecture has to be built in, and what are all the data structures the model is going to use. And then the design model can be assessed for the quality and be improved before the code is generated and the tests are conducted. So once you prepare a design, the developer will come to some conclusion about what the product is going to be, and this design model will be discussed with the customer and they will come to some conclusion whether the quality they have reached is fine or they have to improve the product. And once they are satisfied with the customer's requirements, the developer starts the coding, and then after the coding the test can be conducted. So the design model gives a clear idea about whether the design contains some errors or some inconsistencies or the omissions. That means they wanted to add something, or they have to correct something, or they have to improve something, and are there better design alternatives. So once they develop a design and they discuss with the customer, they can suggest some other better alternatives if they wish to have. And then can the design be implemented within the constraints, schedule and the costs that have been established. So for everything we have an estimation about the timing, some constraints about the technical or any financial constraints, and also the cost estimate. So they will come to some conclusion whether the design can be implemented within the estimated constraint, the cost or the schedule. So now then once they are comfortable or once they are satisfied with these definitions or the decisions, they will keep moving on with the design. A designer must have practiced the diversification and convergence. That means the designer selects from design components, component solutions and knowledge available through catalogs, textbooks and experience. That means the designer, that is the developer, they should have a thorough knowledge and the experience about the design. So they have to go through many catalogs, that is the previous models, the text, the papers, the experience of the different people. So wherever the things are possible, they can take the experience or they gain the knowledge from different varied sources like the catalogs, the textbooks, or the experience from the other persons who have done it, and from then they can select the best component they wanted to build in. The designer then chooses the elements from this collection that meet the requirements defined by the requirements engineering and the analysis modeling. Convergence occurs as alternatives are considered and rejected until one particular configuration of the components is chosen. That means once they have a varied, there is a diversification is once they have the varied number of solutions in different angles, and they analyze all the possibilities and with the respect to the constraints based upon, and then they come to some convergence. That means they come to some better alternative where the other possibilities are rejected while this possibility is considered. So once it is done, the software, they start designing the software. So software design is an iterative process through which the requirements are translated into a blueprint for constructing the software. So it is not a one-time process. They keep on, because the rethinking, reprocessing, everything is done repeatedly in order to achieve the proper goal. So this is not a straightaway process, it is an iterative process. Design begins at a high level of abstraction that can be directly traced back to the data, functional and behavioral requirements. So once they think of some design, the developer, they will have first the abstract level of the component. Then after thinking again and again, they will come into the final conclusion of the lower level abstraction. That means they can find out the design in terms of the data, functional and behavior. That means what data will be used, what data is acceptable, what is the function that can be achieved, and what is the behavior once the product is designed. And as design iteration occurs, subsequent refinement leads to design representations at much lower levels of abstraction. That means once they start in the higher level of abstraction, then by refining their thinking, the thought process, they will come to some low level of abstraction where they can get into the real the design of the model. And now each element, so from analysis model to the design model, each element of the analysis model provides the information that is necessary to create the 4 design models. So what are they? The data or the class design, the architectural design, and the interface design, as well as the component level design. So here once they analyze about the project or the product, then they will come into the design model. So design actually have 4 different components. They are the data or the class design. That means what data we are going to use in the particular design, what is the data structure we are going to use, and what data structure is efficient to implement the product. Those things will be considered in the data or the class design. And then the architectural design, where how the components can be built in. For example, a software cannot be built as a stretch. It will be developed in modules or level by level. So once they develop the module, that means they are finding some different components of the system, and then how the components can interact with one another. So that is the interface design. So once they define the model, then they will make the architectural design in such a way that how the relationships are built between the major components of the software. And then afterwards they look upon the interface design, where how the components are going to communicate with each another, and then how they are going to interoperate. That means they are going to operate within one another, how it is within the system as also with the human we are going to use the system. That is the interface design. And finally the component level design. This transforms the structural elements of the software architecture into a procedural description of the software components. That means every component is as a blueprint is there. Now how each component is going to act, or how each component is going to do the process, that is called as a procedural description. So this is the way the analysis model is transformed to the design model. And now what are all the task set that is in a software design? Let us see about one by one. First is examine. What to examine? Examine the information domain model and design appropriate data structures for data objects and their attributes. So every data has some attributes or the qualities. They have to first of all find out the information domain, on what basis we are going to give the variable or the data structure, and then the attributes of each and every data. And then using the analysis model, select an architectural style and the design pattern that are appropriate for the software. So once they have developed the analysis model, based on this analysis they are going to choose the better architecture. And then partition the analysis model into design subsystems. What the component level, they are going to divide the system into subsystems so that they can achieve the process easier and also in an efficient manner. And then here we have design the subsystem interface and then allocate analysis classes or functions to each subsystem. So here actually what is this two points mean is, once they define the subsystem or a module of the particular software, they are going to allocate the analysis classes or the functions. That means what each subsystem is going to do and how this subsystem is going to communicate with the other subsystem, that is called as an interface. And in the next step, create a set of design classes or components. They create a set of design classes or the components, and then here translate each analysis class description into a design class. So once they analyze, they have formed some class and they has to be developed into a design class. Check each design class against the design criteria. Consider the inheritance issues. Actually, what here, this is the main point. Inheritance is mainly used to reuse the classes. So once you find out the classes or the components of the from the analysis class, we have to find out how the inheritance concept is used to derive from one class to the other class, which will save much of the design time or the product development time. And then define the methods associated with each design class. So find out the methods. So data and methods, they are all the encapsulation of your class. Once the data is defined in one section, the methods has to be associated for each design class. Evaluate and select the design patterns for a design class or a subsystem. So once you assign the design pattern, we have to evaluate the for the class. That means you have to find out how much it is going to work out. That is called evaluation. And then design any interface required with the external system or the devices. So far we have seen all about the interface, which is the communication within the subsystem, and now we are going to again define some interface which the system is going to interact with the external system or the device. So that means one system may get data from the other system. For example, a sensor and the home safe system. Okay, so the sensor is the external device which is going to give data to the home safe system. And now how this interface is going to occur, or how this interface is going to involve the operation. So that is found out in this step. And design the user interface. So once the interface between the subsystems, among the subsystems, and also between the external systems are defined, now we have to define an user interface where the design is where the system is going to interact with the user, how the user will give the command, and how the user expects the result from the system. So those has to be designed in the user interface. And then conduct the component level design. So check for every component is working fine. That is called as an component level design, like a design unit level design. Each model will be checked how it is being implemented or being done. So there we have to specify all the algorithms at a relatively low level of abstract. That means we have to clearly define what are all the steps involved to do the particular functions in that component. Refine the interface of each component. So initially we must have defined some interface in an abstract level. Now we have to refine those interfaces for the each component. That means how each component is going to function, what is the data of the each component, how each component is going to interact with the other components, what data is going to give or what it is going to get, and how these components are going together or they work together in order to get the work done. And define the component level data structures. So every component has its own data and the data structures, which for which functionality, which data structure suits the best, the designer has to design the data structures also. Review each component and correct all the errors uncovered. So once the component is built, we have to check in with all the possibilities where there may be possibility of some errors or inconsistencies. So next step is to develop the deployment model. Now the analysis, from the analysis it has come to the design. Now the design has been thoroughly checked with all the criteria and interfaces have been developed. Now we have to develop a criteria which is for the deployment model. How we are going to deploy that model in the customer site, or how the customer is going to use the particular model, maybe in the customer side or in the developer side, how to deploy it. That means how to make the component present in their area or in their vicinity. Show a physical layout of the system revealing which components will be located where in the physical computing environment. So that's all about the tasks of this design. Now let us see what about the quality of the design. How here always the quality is important, and design is the place where the quality is fostered. Provide representations of software that can be assessed for quality. So we have many standards in quality checking. So we have to go by the standards so that we can provide the representation of the software. What is representation is how the design is presented using the tools and all the using the tools and the techniques of how the product can be assessed for its quality. Accurately translates a customer's requirements into a finished software product or the system. Okay, so now here when it also serves as the foundation for all the software engineering activities that follow, because from the design, if the design is perfect, now from there we can get the quality, because we are refining the product in the component level based upon the analysis model. So now the quality comes into role. So once the design is done perfectly, we can expect some good quality in the forthcoming product. Without the design, we risk building an unstable system that will fail when small changes are made, that may be difficult to test, or it cannot be assessed for the quality later in the software process when time is short and most of the budget has been spent. So here, if there is no proper design, we are not able to assure whether the system will be stable. Even for a small failure, the system may be locked out, or sometimes it is difficult to test with the sample data. So without the design, these are all the risks we are going to face. So always we should go for a good quality. The quality of the design is assessed through a series of formal technical reviews or the design walkthroughs. These are all the technical terms to say. Formal technical reviews are done with all the specification design, which is done from the requirement phase to the analysis and to the design. Finally, we will come into a formal technical reviews or the design walkthrough. So we go through the steps whether we have done the product in a perfect way. Now, what are the goals of the good design? The design must implement all of the explicit requirements contained in the analysis model. It must also accommodate all of the implicit requirements desired by the customer. So even though the design gives all the explicit requirements that is asked by the customer, other than that, the system should also be able to provide some implicit requirements which even the customer may not have mentioned. The design must be a readable and understandable guide for those who generate code and for those who test and support the software. So design should have a proper documentation to say it is readable and understandable, so that whoever join the team for coding purpose or the testing purpose, they will be able to easily code and test the software. In such a way, yeah, good design should be. The design should provide the complete picture of the software, addressing the data, functional and the behavioral domains from an implementation perspective. So if you are going to implement the product, if you are going to run the product in the customer environment, how it should be, that is the complete picture of the given software. That is the quality of a good design. So it should be both in the view of data, functional as well as the behavior. That means actually data is how the data will be getting, how it will be output, how it will be formatted, everything, and how it is going to work out as the functional, and how it is going to behave based upon the environment. That is called as an behavioral domains. A design should exhibit an architecture that has been created using recognizable architectural styles or the patterns. We should follow the proper quality standard. Is composed of components that exhibit good design characteristics, can be implemented in an evolutionary fashion, thereby facilitating implementation and testing. That means what is evolutionary is we can keep on improving the nature of the work. So that should be implemented in such a way that it will be upgraded every time the changes has been made. A design should be modular, that is the software should be logically partitioned into an element or the subsystem. That's what the modularity concept. So the model should be well defined so that the design will give a proper expected product. A design should contain distinct representation of data, architecture, interfaces and components. The things are repeated again here. So we should have a proper representation of the data, architecture, interface and the components. A design should lead to data structures that are appropriate for the classes to be implemented and are drawn from the recognizable data patterns. A design should lead to components that exhibit independent functional characteristics. That means here the function, each component should have independent functional characters. That means as a component individually how it is going to perform some work, and then after it is perfect in their independent work process, how it is going to interact with the neighbor modules or the components. A design should lead to interfaces that reduce the complexity of connections between the components and with the external environment. A design should be derived from a repeatable method that is driven by information obtained during the software requirements analysis. So from the phase where the requirement analysis is done with the respect to the customer and the developer, now the design should be derived using an repeatable method. That means we are able to repeatedly make the improvements in the design what has been made, and that should be fully based upon the requirements analysis. A design should be represented using a notation that effectively communicates its meaning. So we have a proper tools for notation, and those notations should be used as a standard.